Hello and welcome to this main assembly tutorial. Today I'm going to show you how to convert roll and yaw into the pitch format. You might not be familiar with this problem, but roll and yaw have a different formatting than pitch. So I'm going to show you how to convert roll and yaw into the pitch format, because it will make it easier for you to write the code and will enable you to write code easier without having to convert them during the script. You have a separate script that converts them for you without you having to do this every time. If you're not familiar with this concept, you can see that pitch have a different formatting from roll and yaw. For example, we have roll here, which has a default position of 0. And if you rotate clockwise, you can see it goes to 0.5, and then to 1 / -1, and then to -0.5, and then it goes back to 0. If you take a look at pitch, you can see the default position is left 0, and if you go up, it goes to -1, and then back to 0, and then to 1, and then to 0. So it's basically double the amount of of space, of degrees, than roll and yaw. So today I'm gonna show you how to convert roll to pitch. So to quickly explain what we're gonna do, you can see here that I start off with an input, and then I'm gonna remap this input / readjust its lowest and highest values from -1 to -2 and from +1 to +2. It basically multiplies the roll with 2, basically, but it's cooler if you can say it like that. Then I check if roll is higher or equal to 1, and if it is so, I set roll to 2 minus roll. For example, if roll is 1.25, it's higher than 1, of course, and then it will run the 2 minus 1.25, which will result in 0.75. Basically the same in the next line. You can see here it's basically just the same, but I'm gonna throw a negate block on it, or multiply it with -1. So I'm gonna check if it is if roll is less or equal to -1. Then I'm gonna set it to -1 times set roll to -1 times 2 minus roll. For example, if I have -1.65, that is of course lower than -1, and then I will run -1 times 2 minus 1, 65. So that will of course give a result of not 32, but 0.35. I'm sorry for that. If none of these are true, for example, if it is equal to 0.25 or just 0, then none of these will activate, and then it will activate this one, which will not change the value of roll, simply. And here we have, at last, just export the roll as an output. So now we are here in main assembly with this little cute boy. He's so cute. But let's see. Let's start off by starting in assembly mode. So I have of course made my little bot here, which will be able to move 3 different axes, so I can display the roll, pitch, and yaw. Down here we have my controller, and here we have my CPU. So let's just begin. So after start, I'm gonna rename my CPU to roll yaw converter, just for the sake of having good names. I also call my seed for main, because that's just what I like to do. Don't ask me why. Other than that, I don't think there's more. So let's start off by taking in an input from the gyroscope. This will start off by doing the roll. So convert roll to the pitch format, we will be needing a lot of blocks. So let's start off by everything in the logic section. We need 2 binaries, this one and this one. You can duplicate blocks by holding control and dragging on them. We need some comparators, like in Minecraft. Ah yes, Minecraft words. We need some NOT gates, and that is basically all we need in logic. Then we need something in climbing. We need this remap range. We need that to be right next to roll. Other than that, we need some math. We need a lot of math. So we need some multiplications. Here we have the multiplications, 4 of them right here. And then we also need some subtractions here. And also some multiplications up here. And then some additions here and here. Also, we need some constants, 3 to be exact. This one will be -1. This one will be 1. And this one will be 2. Great. Now we only need some negates, and they are on the sign. When we say negate, and here. We're just gonna move this up a bit, and here. Yes. Okay. The last thing we need is an output, which will output our last converted roll, which we will call converted roll. Creative name, I know. So, after start, we need to change the remap range. Because roll has an output from -1 to 1, we need to have this to be the double, since the pitch format has double the value of the roll and yaw format. So, let's start off by making this the roll format, and then we need to have this as a double format. So this will need to be -2, and this will have to be 2. We basically multiply every value with 2, but this is just way better than looking at than a multiplication. So that's how it is. Don't ask me why. Actually, please don't. But then we need to put this in here, which will start comparing this to the input B, which we will move this constant into. It will say if this is higher than this. So if the remap range is higher than 1, it will send out a 1. And then we convert it into the binary. So everything else than a 1 will be 0. Then we move this binary into this multiplication, and then we move an output of the remap range over here. The reason we do this is that this one will only output a value if this one is true, since this one will output a 0 if it is false, and 0 times this value will be 0, therefore no output. The next thing is we need to have this one to have this next constant. This will be 2. The 2 constant will need to be multiplied with this 2, because this will only be done if it is true. If this function is true. So now, if this is true, this has a value of 2, and this has a value of the remap range. We need to multiply these with subtract these with each other. So this will be 2 minus the remap range, which will give a decimal right around like from 1 to from 0 to 1. And then this function is actually done. This button function is actually done. We just drag that right into here. While we do this, we can put this here and this here, which basically give this one 3 inputs actually. So the next thing we have here is actually a bit similar to this one, but negated. So what I do here is I start off by taking this one like before and putting that here, and then I will say this one opposite to this one, because this one is negative. I'm looking for is less than. You can see here under the second I think the third line, you see that if it is smaller than if this one is less than this one, it will give out -1. But we actually want a 1. So what we do is we pull that through a negate block before we put that into binary, which will basically reverse the output of this. Then we have, after we have this one, we'll have to, of course, put this into this modification, so we can access this you can access this function and make it actually worth something instead of just a 1. So what we do is we take this one and negate it like before, so we have a positive number instead of a negative, which is what we want. Actually not, yeah, actually positive instead of negative. Yeah, never mind. Don't mind me. Next we do is we take this one, right, like before, and take the binary. So 1 times 2 equals 2, 0 times 2 equals 0. So this will only be, this will only have a value if it's true. Then we multiply these two values. Actually, we need to subtract these values. 2 minus this one. It's very important. These two need to have subtraction. This one needs to have the value of 2 at the top one, input A, and the remap range output needs to go into the bottom one. We're almost ready to put this into this. We just need to negate it once again because we negated both values in before. So we need to negate it once again to have a good output. Here. Now we have both outputs of the if statements. Now we just need the else. So these two are not statements. I'm not sure if this is the most efficient way of doing it, but I'm too tired right now to find out if there's a better way. So I'm just going to do this. We test out for taking outputs of the binaries, which will make this 0 if these are true. So these will be false if these are true. I'm gonna multiply these to make a this statement, which will have a total maximum of 1 and the minimum of 0, because it's binary inputs and they're multiplied. So here we have a thing that is only true if none of these are running. So we have multiply. We need to multiply this with our remap range, but this will only be done if none of these are currently running. And then we have this. Just drag and drop that right into here, and then everything in this roll yaw converter is done. We can actually before we go into do any further work, we can actually convert this into a perfect square. This was totally coincidence when I found this out, but this can be a perfect square. You can put these down here, this down here. This needs to be moved here, and add, and this one, and you can just take these ones and move them down like so, and then we have a perfect square. It's very space efficient, this code. I'm very proud of it. So now we have this output called converted roll, which will give a pitch formatted roll output. We go into main, which is my seat down there, and we'll take out the roll yaw converter, which is the CPU I have. Then we take the output we just made, which is now an input for our main, because it's an output into an input. Great. Makes sense, it does. But when we have this, just take a mask and use the debug function to actually make a value come up to the screen. So we can just call this one for roll, and then call it a float with 2 decimals. When we have this one, we can actually, as far as I know, play the game, and we'll have a roll value in the bottom left corner. And if you roll, you can see it does perfectly fine. It's exactly like pitch. In the middle, it has a value of 1, and if it goes down, it goes back to 0, 1, 0. Which is basically how it works in pitch. Of course, if you want pitch to work too, you can just take the normal gyroscope, because pitch is already in the pitch format. Weirdly enough. You just take the picture, and if I take enter, you can see my pitch works fine too. Of course, if you want to convert the yaw into the converted yaw, it's basically it's the exact same method you just did before, just with the yaw component here, and make your own output called converted yaw. There's nothing else. It's just the same. Thank you so much for watching. I hope you enjoyed the video and that you learned something. I also hope you understood what I said. I can't come off as very like complicated sometimes. I normally speak very unclearly, but let's see if you understood what I said. If you really enjoyed the video, please hit the like button. I'm not sure if, I'm pretty sure it won't really take off my channel, but it just makes me very happy that that people who learn something from my videos actually end up liking my videos. So if you enjoyed it, please like, and have a good one.